Hi, I am Advait, and along with me are my teammates Soham and Ojas. Here we are going to tell you about signal compression in a very layman terms. So before jumping into signal compression, let's know more about what signal exactly is. So signal is basically some entity which can be either wave that carries information. So uh, in signal we have phenomena called signal processing. The objective of signal processing is to preserve the information contained in the signal and extract and manipulate it when necessary. So in signal processing, we have the phenomena of signal compression. So what exactly signal compression is? Let's get to know about it. So signal compression is a process of removing the redundant information from the signal and reducing its resolution, whereas keeping the information of the signal intact. So why exactly do we use it? It is basically used to remove the redundancy, or maybe it is basically due to limitation of channel or to reduce the size. So let's talk about the application of signal compression. So in our day-to-day life, we do knowingly or unknowingly use signal compression. For example, while sending a photo on WhatsApp or social media, we see that if a photo is of very high quality, when we send it to another person, the quality of photo drastically drops, which is mainly because of signal compression. The photo is compressed in such a way that its information is still intact, but the size is reduced so that it can be transmitted easily and can be stored without space issues. Apart from that, we also have another example for like in a phone call, we hear the voice of another person a bit different as compared to the person speaking live. This is because of signal compression we see in the phone. Another example is when we stream on YouTube, when there is a limitation of network or bandwidth, we see that our quality of video and audio drops drastically. Usually it is called 144p. And here we see that it is compressed, yet the information is intact. We can feel that there is some difference. So let's look at some demo of the signal compression.
Thank you, Anvit. So now we'll move towards audio compression. So you might have noticed that in Spotify, so Spotify actually allows you to control the audio quality of the music that you're listening to, and it's located under the data saver option. So this is an example of audio compression happening under the hood. Basically, it reduces the quality of the audio by a small margin, so that the size of the music becomes smaller, and subsequently the your data that you're using to listen to the music becomes so it gets saved. So we are now going to show you a demo of how this auto compression actually works. So basically, I'll just run the original audio file that we have used. Okay, so that was the original file, and now we'll listen to the 90% compressed version of that file. Okay, so these are the graphs of those audio files. So here the original audio signal, you can see that the graph is ranging from -1 to 1, and it's quite sharp. Okay, so and in the 90% compressed version, you can see that the range has been reduced quite a lot, and you might have realized that the sharpness has also been reduced here. So next we'll look at image compression.
In image compression, we basically take an image and alter the pixels of the image. So initially, let's consider if there are 4 pixels and we want to compress it, so we can drop alternative or middle 2 or any of the pixels depending upon some calculations, so that we can keep the information as it is but reduce the number of pixels, which will ultimately reduce the number the data reduce the data in the image. So I'll show first one picture. So this is basically Spider-Man. We all know him. Yeah, so when I zoom it, you can see the pixel size is smaller, and upon zooming for nearly 4 to 5 times, I can get this pixelized image. But now, when I compress it and open a compressed image, you can see within 2 to 3 zoom ins, we'll get a pixelized image, and the size of pixel will also become very large. So I'll just execute the code. In the code, we are basically compressing an image. We are taking the input from the user, the name of the image, basically the path, whether user wants to convert in JPG or not, the quality and resizing ratio. So we won't deal with resizing ratio. We'll just provide him the image. We'll convert it to JPG as it is a compressed format, and most of the images are available in JPEG format only. So, and the quality also. So we'll try to decrease the quality as much as possible to a certain extent. So I'll just execute. If you're really a geek and want to learn more about the code, we'll provide you the link of our blog in the description of the video. So here I'm executing the code. I'm trying to convert the PNG image, that is spiderman.png, into JPEG file, and we'll try to lower the quality to 50%. Yeah, the code has been executed and we can see the result. So the result, basically this is the input that we have provided, which is showing that the image name, it is converted to JPEG, quality has been reduced to 50%, and resizing ratio, that is as it is. So image cell, that is 360 pixels by 326 pixels. The size before compression was 47.83 KB, and now after compression it is 16.77 KB. So we can see a drastic change in the size of the image, and this change is nearly about minus 64.94%, which is more than the half, that is more than the 50%. And now we'll have a look on this Spider-Man. So image will be named as Spider-Man compressed.jpg. So we'll search for it. Yeah, here we go. We got our image. Yes. And on, yeah, so you can see a much distorted image as compared to the previous one. We can have look side by side. There we go. We can compare the two images. This is the .png image, which is uncompressed one, and this is .jpg image, which is the compressed one. If you're really able to see and notice, I don't know whether you will be able to do from this video quality, but yeah, definitely as being an first observer, I can notice that the image quality has been reduced. So in the first image, I can see a quite clear picture, whereas in the second image, I can see that the image is little distorted, or we'll say pixelized. Yeah, we can see that though the images have reduced their quality, that is the first image is quite clear, the second one is pixelized, but we can observe Spider-Man in both of the images. That means we have lost the data but not the information, and this is how compression works.
Thank you, team. Dear viewer, we hope that you had a wonderful time watching this video. I believe you got to know some information about signal compression that you already didn't know, its application, and why it is necessary in our day-to-day life. Finally, we would like to conclude by thanking our professors, Professor Kirat Talele, Professor Najib Katte, and Professor Manisha Bansode ma'am to provide us this opportunity for guiding us and motivating us to make this video. And feel free, if you have any feedback, to write down to us on the comment section below. Also, do drop a like if you like the video and share it with your friends.